Hey, Alex here from Blacksheep IT Consulting, and we are on the second part of our video series on how to use the OCI Oracle Cloud Infrastructure REST API, and strictly the REST API, not any SDK, Java or otherwise, to connect Siebel to, well, all the good OCI services. So if you watched the first part, and I encourage you now, if you haven't watched it, to go and watch that first part right now before you watch the second video. In the first part I demonstrated, and you see the result of the demonstration on your screen right now, I demonstrated how to get the sentiment for a given text, in that case the comments field on Siebel activities, which is of course representing emails in this example here. And you see the sentiment displayed as a series of icons, one icon next to each record, so to speak. And so we have negative sentiment for this one, we have a positive sentiment for this one, neutral, and so forth. So you have seen the demo in the first part, and today in this video I would like to go deep down the rabbit hole into the Java part of this very solution. So what you're looking at right now is the main function on OpenUI JavaScript that is running in the browser, as you saw it. So when I press the button, basically what happens is that a URL is prepared and a payload, and that payload is sent off to OCI and the result is processed. But before we can send that request successfully to OCI, we must generate that signature. And we've talked about that in the first part. The signature is computed from various parts of the request itself. So you basically have to have the request, then pass it on to a function that calculates the signature, then take the signature, put it in the authorization header, and then you can send the request to OCI. And to implement this, I've written a Java business service in Siebel. And that Java business service is called from OpenUI, from the browser. So you see here, at the core of this function, there's a fetch, a REST request is being sent to the Siebel REST API. That's Siebel, not OCI. And I'm calling the business service called BCRM OCI adapter, and I'm calling the getAuth header method of that business service. What am I passing in? I'm passing in a body with the request method of the request, so that'll be post, and a path to a configuration file. Let's check that out, where that comes from. That comes from a default setting here. That is the file, as you can see, on the Siebel server internal application container. That is the internal Tomcat. That's the OCI config file. This parameter, of course, questionable to put it in a browser-side script. This is just a demonstration, of course. Make things easier. You can make things a little bit harder for the bad guys in putting this information on the server. And we also pass in the URL to my custom business service, the URL of the request, which has been calculated in a previous function. We will go through the JavaScript, the browser-side portion, in the next part of this video. So let's focus on this very business service. So it's a Java business service, and so here's some Java code, which is the business service implementation. And that code is shared with you on GitHub, so you find the link in the description. And let's see what it does. It's a typical Siebel Java business service implementation. I will not go into too much detail on Java business service implementation itself. If you have never done it before, might look a little bit odd, but if you know what I'm talking about, that's the way you do it. So you notice at the import statements that, for example, Siebel property set and Siebel business service exception classes are imported. So that means you need to have the Siebel jars in your class path and so forth. And let's get over the imports. That's a little bit too much. And here's the main class. So when you write the Java Business Service, you have to implement a class that extends the Siebel Business Service class, and you have to implement one exact method, a method called doInvoke method. And it gets from basically the Siebel server calls the Java Business Service through a HTTP call to the internal Tomcat, passing the method name, the input property set, and of course the output property set. So this code is serving multiple purposes on OCI integration, and I recently added the get authentication header or get auth header method. So I basically check the method name if it equals get auth header. So this code will then be executed on the Tomcat. First of all, let's get that configuration file path. Let's get the profile. We don't pass that, so it's defaulted right below here. So there's default configuration file path, there's a default profile, which is called default. A profile in the OCI configuration file. There's a config file reader provided courtesy of the Java SDK from Oracle. So this one is used in this function to actually read the configuration file. You see, passing in the file path and profile, get back the configuration as an object. So let's quickly talk about that configuration file, get it out of the way. This OCI config file is at the heart of any integration with OCI, and it represents, if you open it, the necessary credentials for a valid user account on OCI to connect. You have the user OSIT, the user fingerprint, the tenancy OSIT, the region, the path to the private key file of that user, and here's another parameter used in Siebel very often, the compartment ID. So this file resides, in my case, directly in the web apps folder. I put it there along with the private key. So it's safely tucked away on the Siebel server. It's not on any case on the web server, etc. So getConfig file is really a very short function, literally taking that path to the file, and employs the config file reader class from Oracle to parse the file and return the configuration. So it's really just a wrapper function. So now that we have the configuration, the content of the file, so to speak, we can call the custom method getAuthHeader, which is the Java method, passing in the configuration and the two property sets, input and output. Okay, and off it goes, of course, to call that method here. So what does the method do? First of all, we read the credentials from the configuration object. So basically reading the file, the content of formerly in the file is now in that config object. We also read the HTTP request URL property from the input property set and the request method. So the URL is calculated by the browser side script, and the request method is, in our case, always post, because we expect not to use any get methods. Well, that might be flawed, but in the use cases we are showing in the example, it's always post. So what to do to calculate the signature? So here I am on the Oracle documentation for request signature. You'll find the link in the description, and it talks about in great detail about what is required to correctly compute that signature. So it says here you need an API signing key. Okay, yeah, that's what we try to do. And here's the summary of steps which are outlined in the first video. But very briefly is you need a request, well, HTTPS it is. You need that signing string, which is based on parts of the request. And now that's what we talk about. And then create a signature from the signing string using your private key and the SHA-256 algorithm. And then use that signature and add it to the authorization header. in the request. So basically, my business service returns that signature so that the other side, in my case, a browser side code, can pass in the authorization header to Oracle Cloud. So let's scroll down a little bit here, as the first thing the code does is actually a little bit down here below. It's the key identifier. So as part of your signature, or you need a key identifier. And it says quite clearly here the key ID parameter, so to speak, in the authorization header must be a concatenation of the tenancy OSID, the user OSID, and the fingerprint. So 3 ingredients we already have at this point. And exactly in this line here, we calculate that key. Well, calculation is really like, okay, it's a calculation, it's zeros and ones doing the thing. So these 3 credential details are put together, separated by slashes, forming that API key. Okay. So back on the Oracle documentation page, we can see there's even a test. Well, it's not working, but there's some test code that they share with us. So here's an example of the signing string, right? And you can see that authorization header would be for a GET request, or let's scroll down for a POST request. Yeah, would include that key ID. You see? There you go. Right? They leave out the signature itself here. So, well, the signature here, that's the signature. And that's our key. So the signature, of course, has to be calculated then. What the documentation is, well, the examples actually are quite clear about it, but the documentation is not really clear that the date you're using to calculate your signature has to be in an exact format. Okay, so let's take care of the date. So it's a current timestamp in seconds, and the date will also be part of the signature. So it's very important that it's the same date and time and in the same format. And the next few lines of code take care of this. So I'm using a simple date format class from Java to create exactly that format in the US locale and set the time zone to GMT. That's what I got from the examples and also the example code on this Oracle blog post that we discussed in the first part. So now I can generate a timestamp. And that timestamp you must use all the way down. Don't make a mistake like I did and calculate that date in some other place again, because it will be a different time then, right? Okay. So next line of code is actually fetching the private key. We have the private key path from the configuration file. So now it's time to read that key because we must use it. So here's the little helper function that reads the key. So it gets the path to the key file. Remember that code runs on a Tomcat server, so it must be reachable from that Tomcat server. The Tomcat server is adjacent to a Siebel server, obviously, but still, you have seen where I keep the key file right next to the OCI config file, and it's basically a stream thingy. Any implementation would probably work that returns a valid key. The code I'm using here uses the PEM read private key implementation. So now we got our private key, and the next thing is we need to generate an HTTPS request and then sign it or use the request to calculate the signature. So what the code does here is cater for 2 different HTTP verbs, or actually it caters for GET, and it also caters for PUT or POST. And POST is the most important for the Siebel integration, so I'll focus on that. So we create a new, a POST request, which is an HTTP post using the URI. The URI is passed in from the caller to that Java Business Service. It has calculated the URI already. And then, of course, we need to get the body. It's a post request after all, so there will be a substantial JSON body. This body is passed in the input property set. Let's go back to the caller. So here's the code on the browser side that has calculated the URL and prepares the data. Notice here that P data, that post data, is the input property set for the Java Business Service. And we populate the HTTP request body property with the stringified payload. Now, the payload is calculated. It's the JSON payload that the request expects. So there's ample JavaScript here to generate that payload, but it must be a valid JSON object, which is then stringified as the request, the future request body, so to speak, and the whole data structure, the input property set, if you will, is then stringified and then sent over to Siebel, to the, again, we are still talking about the Java Business Service being invoked. So this is where that payload comes from. And here we get it again as a string. We call it JSON here, it's still a string from that input property set. And now converted to a string entity. That's using Apache library here. And this is the line of code where we actually add that JSON to the body of the HTTP post request. So now the request is complete in a sense. It's a valid HTTPS request, but if you send it off right now to Oracle, it will fail. It will come back unauthorized because you don't have the signature yet. And so here is the next major function in this Java Business Service to get the signature using the ingredients, the API key, the private key for encrypting it, the entire HTTP post request, that very important timestamp, which is in the exact format, and this is the output property set. So we pass it on here so it can be populated along the go. So let's check out that getSignature method. So before we go into that method, kudos to Abhijit Bora again from Oracle, who has posted the entire Java code in a blog post. You find the link in the description. So what I'm showing here is not my code. I want to make that clear. I used code from Abhijit here that he posted on this blog post. You don't have to copy paste it from the page. There's a link down here where you can download the class file. But it's not a Siebel Java Business Service. It's a regular Java class that would do the same thing and even call the post request, but I converted it to a Java Business Service. So just to know where the majority of the code you see in the next minute come from. So here's the getSignature function, and well, there's the necessary string that you have seen in the Oracle required signature RSA SHA256, and the method. We can now use the HTTPS request and just get the method out of it, which is post or get, for example, and convert it to lowercase. We have it for later. And here Abhijit does something that is a way of implementing it. So it's basically for each type of request, get or put or post, you have a list of required headers. And it's implemented as an immutable map of a string, namely get or post, for example, and a list of strings, and it builds that variable here. So that is maybe something you would do differently, but in essence it tells us that, for example, for a get request, you have 3 values in the required header list, the list of required headers. And in put or post, you have a few more values, including content length, content type, and X content SHA256. Notice that we are using X x-date here. Now let's talk about x-date a little bit. So if we read the Oracle documentation on the required headers, it says for get and delete requests, when there's no content in the body, the signing string must include at least these headers. Request target as described here, so you can follow to IETF and read it. Host and date or xdate. And if both are included, Oracle uses xdate. So xdate is kind of the preferred way. And at least in my case, I had difficulties setting the date header. I'm not sure why, but once I changed it to set the xdate header, then it started working. So I think that's a good piece of information. And here's also the information we have seen implemented in Java, that for put and post, you have 3 more required headers. And these headers must be used to compute the signature, but they also must be present, except the pseudo header request target, in the post request itself. So these few lines we see here, the required headers variable is essentially an implementation of that information in the Oracle documentation. And to sign that string, it actually uses a library that you find in the imports, Tommy Tribe. So that's a library that specializes on request authentication and signature generation. So it's a very clever move from Upjit to use that library and not implement all the nitty-gritty details of SHA-256 encryption and signature creation. Here, there's a library for that, and yeah, it's 2023. So what the code here does, it takes the required headers and basically iterates it. Remember, it's a map of sorts, and uses it to create a map of signers. Signer is a special class of that Tommy Tribe library. So it's a string, and that's the key. So it's like, okay, for get we have this signer, for post we have this signer, right? So that's what happens here. Building the signer using the necessary stuff that a signer needs to have. Well, yes, there's a build signer function even. So that returns a signer made out of the API key, the private key, the request method, which is essentially, well, get or post, the signature algorithm, and the full list of required headers. So that returns that map with signers. Okay, and now we can start to think about that signature with a special function, again, sign request, where we pass in the request itself, the timestamp, the required headers map, the map containing the signers for each request type, and the output property set again. So it's about time we populate some output properties here. So let's check out sign request. And so here it is. So first we extract the method from the request again. So we have get or put or post. That is probably never reached. We don't use options. We could use. And here it extracts stuff from the request. Remember, it's a valid HTTP request, but it's not valid for OCI yet. So first of all, let's extract the path. And I decided to write that path into the output property set so that my code on the other side, waiting for the reply, can use it. I do the same with the xdate. Sorry, don't add it to the output property set. That happens in a different way. But the header, you see that the xdate header is set to that exact timestamp. And the host header is set here as well. So basically the HTTP request is here enriched with headers. So now we have xdate and host set. And we also set the output output property set, we use it to store the host portion of the request. And this part of the code takes care of put or post. So if you use Siebel, you will probably use post. So this is the code that runs, adding that content type header as required. Application JSON it is. And then taking care of the content length header. You see that it actually has to extract the body again of that post request and takes the length, measures the length of the body literally, and passes that as a string into the content length header. And the output property set gains a new property here I called header underscore content length with the same information. Again, remember, I'm not fond of sending the request here in Java on the Java side. I'm fond of getting the necessary headers and signature to call the request from the Siebel side. So for post request, where we have a body, it's also required by OCI to encrypt that body. Or it's not really encryption, but anyway, it's a hashing. So here is a calculate SHA-256 being executed on the extracted body of the request, and that result is added as the x-content-SHA-256 header to the request and passed in as an output property in the output property set. So the interesting part is that calculate SHA-256 function. Let's find it. And this is a very short function, so it's calculating the hash of the body and it's encoding it in base 64. So that's what the Oracle documentation also requires. So at this point here, our request has all the necessary headers and body to be valid, but it does not yet have that signature. But the contents of that request can be used now to generate the signature. So here we go. The headers first. The headers to sign are extracted from the request using that required headers map. So basically it's a extract headers to sign is a helper function down here, which goes about the business to read that map of the required headers. Remember, 6 headers for a post request, and it extracts those values and returns a map of strings. And so we can use that headers map in the calculate signature. So the real nitty-gritty function, finally we arrive here at calculate signature, passing in the method, the get or post, the path that we extracted, the headers that we need to include, and our signers map here. Remember, there's one signer for each method here. So let's check out calculate signature. And that's surprisingly short because it uses that special Tommy Tribe library, which has all the necessary bits and pieces to sign, create a signature for an HTTP request, provided you're able to provide the method, the path, the list of headers to use for signing, and that signer class. So here you see that we, from the signer map, we get the signer for the correct method and then return whatever the signer uses or returns when you call the sign method. So it includes the method, path, and headers, and to string. So it's returning a string. And that's thanks to the good people that created the Tommy Tribe library. Now you might be a little bit disappointed because you wanted to know exactly how to create a signing string, and it's using that library, which is kind of black boxing it. No big deal. If you really want to get down the rabbit hole, you can see it all in JavaScript. Remember that the Postman workspaces that you fork, or Oracle's Postman workspaces for the OCI API, have this pre-request script that we already discussed in the first video. I just wanted to point it out here. You find all the links in the description, and the pre-request script does exactly the same thing as I implemented in the Java Business Service, albeit in JavaScript. So you could theoretically run it in a browser, which I would not recommend. It's very insecure. Or you could run the entire JavaScript on a server-side JavaScript engine, such as Node.js. But it's Siebel, so we have the Tomcat, we have Java Business Services, so I can basically convert that logic to a Java Business Service. So again, you have enough to read here how to calculate exactly that signing string here. And just as a reminder, we also have seen this in the first video, how does the signature finally look? The whole thing that you have to put in the authorization header. This is the whole thing. So it starts with signature, version 1. Here's the key, that concatenation. Here's that algorithm section. Here's that header section. And here's the signature. And that signature is base64 encoded and encrypted with it's an encrypted thing with your private key, and it's base64 encoded as per the documentation and specification. So it's now very clear that that signature is unique to the request. So if you tamper with the request, if you change any bit of it, any byte of it, the signature would no longer match the request, right? Especially the body content in a post request, the date, any header, etc. So that's the specification, and we have, of course, to deal with it. Okay, back to our Java Business Service, which is now almost done, as it has calculated that magic signature, and now, of course, sets it as the authorization header and returns the signature, which is just, in technical terms, it's just a string. And so we're back to the getSignature function, which we invoked. So here's the return of the sign request function. So we have our signature and we return it. So we're back to the function, the getAuthHeader function, the main function that is called. So we have now worked on put or post requests mostly, but the same happens for get request. So we have the authorization header as a result of the getSignature function. Same for get. It's a little bit easier to get it for a get method. And all we have to do is send that information back as soon as possible using the output property set. So I use the syntax here, HDR underscore, which you might recognize. Authorization, it's just a property in an output property set, but now has that string. And here's the magic timestamp, which is also passed back in the output property set. So with all this information that we have collected in the output property set, the JavaScript or anybody who called that Java Business Service in Siebel now has the necessary information to put together a valid request to OCI. And at this point, I would have hoped that this is shorter to explain. It might just be OAuth 2. I don't expect it to be basic authentication, but yeah, that's the way it goes. So we're back to the JavaScript side where this fetch has gone on, and basically that's invoking the Siebel Business Service, which is a Java business service, which runs the Java code you have just seen in the past half hour. And so we get a result back. We parse that to JSON. So that's the output property set of the Siebel Business Service. We still have the payload we generated. We have the URL, and we have an action, which is what we want to do on OCI, for example, do a sentiment analysis or so forth. And there's the function that actually then makes the OCI request. So here I'm using fetch, of course, and this is the cliffhanger for this part of the video series. So in the next episode, you will actually see how the JavaScript side is implemented. And here you can, of course, think of, if I have a business service that I can call to get that authentication header and all the other important stuff, all these headers that I can set, I can use that from any place inside Siebel or even outside Siebel to put in the base portion of an HTTP request and get all the information to make it a valid request to the Oracle Cloud. And this does not have to be, not necessarily be done in JavaScript on the browser side. It can be done on the Siebel side as an EI HTTP transport, or you have implemented an outbound REST service and you have a filter service to use this service as a filter service to populate the headers, etc. So anything goes with that abstraction layer we have created. We have a business service which can always calculate the correct header. And now let's go back one more time to the Oracle document, where Oracle on this page explains to us the exact syntax for the authorization header, as we have just witnessed. So very clear in saying here the signature must be base64 encoded, RSA SHA 256 hashed version of the signing string. So you need to calculate that signing string, then hash it, and then base64 it. And that's what happens. So with this, I say thank you for watching this video to the very end. I know it's been a wild ride through the worlds of Java and hashing and private keys. And I hope you enjoyed it, and stay tuned for the next part of this series where we'll put all of this together. Thanks for watching, take care, and bye-bye.